Hi, and welcome to this quick tool review. This time around I have some interesting acquisitions I've run across and like to share them with you. Starting with the first one, this was a major find. It's a little bit unusual. So it's a Volhopter boring head that also lets you boring and facing, because you hold this disc and while it's rotating and it moves out and lets you face. I've always wanted one of these. I think they're beautiful. This one, however, is unusual in several ways. One, it was heavily used, but it's damaged in a couple ways. This knob, the shaft that this knob's on, is bent, and we'll see if we can fix that at some point. Also, almost every Volhopter UPA3 out there, including calling the manufacturer, said, oh yeah, all these shafts are removable. This is a Morse taper, and I wanted an R8, so I was gonna get it. Although the person that was selling it did warn me up front that it's non-removable. Well, it really is non-removable. Even the distributor for Volhopter here in the United States didn't know that they had any models that weren't removable, which I think is really funny. Unfortunately, it didn't survive shipping very well. The box got totally trashed. It's broken in multiple spots. I sort of pushed it together and glued it together a little bit, but there's still some pieces missing, like this guy belongs somewhere over here. But it's a great find. It's a beautiful boring head. They're all hardened and ground. They're just beautiful pieces of tooling. And so I wanted one for the sheer beauty of it. I didn't need one. I have other devices do the same thing, just I collect tools. So I did notice that the dovetail, the gearing on it is a little stiff, especially at the end. It took quite a bit of cleanup just to get it to go flush with the body again. It was sticking out, a quarter of an inch, and it was stuck. So that seems to be a little bit better, but at some point we're going to see if we can tear this down and fix it. Next up, I have a couple of books. First, Metal Cutting Tool Handbook. This Metal Cutting Tool Handbook is in 7th edition. It's from Industrial Press, and it's from the United States Cutting Tool Institute. And its latest edition is from 1989. And they cover reamers, counterbores, taps and dies, milling cutters and end mill selection, hob selection, gear shaving cutter selection, and engineering data. One of the things that attracted me to this book immediately when I saw it was they talk about jewel geometry and then show you how it affects chip formation. And that's really interesting to me. Very cool features in a book can help you improve your grinds if you're doing high-speed steel in your grinding tools, or even carbide for that matter, which it also covers in some detail. They've got feeds and speeds. They also show you modifying drill geometry and what it does to the chip formation, which is just absolutely fantastic. They do the same for all the different cutting tools in here. So that was an interesting book. I need to read a lot more into this one, but a really cool find. Next up, I have a book called The Grinding Wheel by Kenneth Lewis. This is an old book, 1959, and it covers all different kinds of grinding and setups, ways to improve functionality, things that cause problems with your grinding. I haven't obviously had a chance to read the whole book by any stretch. I've just bounced through it, but it's a pretty interesting book. Even covers burr bits and mounted wheels for jig grinders and that sort of thing. And they cover all the different types of grinding and how you go about the process: internal grinding, crush grinding, form grinding, surface grinding, grinding non-metallics. It's a pretty interesting book. So even though it's out of date, there's not a lot of books on the topic, so I'm going to enjoy looking into this one. Next up is an unusual device, which I'm hoping is going to work out for me in TIG welding. And it is an armrest available on Amazon. It's got adjustable heights on it at several levels. I think what I'm going to end up doing is changing its mount on here. It's currently got it so that you can do a compression mount on a fairly wide desk or piece of 1-inch aluminum, as in my case. And it lets you, it's all bearing, so it lets you get a good support for your arm to do some TIG welding. Because normally you're trying to get your pinky on something to control the weld, to control the position of the tungsten very accurately, and this will help in those situations where you can't do that. They have other welding positioners. This one was fairly inexpensive. It's Glow Rider. And again, I'm going to replace this piece with something that mounts on a shaft that goes vertically so that I get more height adjust, because sometimes this is not going to be high enough to do everything I need. I think in a lot of cases it's going to work out, but we'll give this a shot and I'll let you know more as I use it. It's fairly inexpensive, so it might work out to be a very economical solution. Some of the welding positioners are quite pricey. Next up, we have some end pieces for lock line, and this is the 1/4-inch nozzle Rama. The Nozzle Rama pack. Okay, I guess that's what they're calling it, Nozzle Rama, kind of like Wonder Rama or something like that from my childhood. Anyways, I thought a couple of these tips would be great on the surface grinder. I noticed Robin Renzetti and Tom Lipton had some ends that look very similar to these on their surface grinder, and I thought I'd give them a try since Lockline did all the work for me to get them in plastic format that'll just mount right on the end of the lock line. They've got a whole variety here, so we'll try a couple of these out and see how they end up working for us. Next up, we have some roller chain links for heavy duty roller chains. And if you're wondering why I have these, well, check out Curtis at Cutting Tool Engineering down in Australia. His channel's fantastic. He works on big machinery. He was recently making a collar for his bore grinding setup, and rather than make a, normally if you were going to have something clamp around the outside, you just do 2 Allen screws on either side to tighten down, but instead you can do 1 Allen screw and a hinge, and these heavy duty chain connecting links make great hinges, as you will see in his project. I got 3 different sizes to try out on my next project. So if you need a double articulated hinge, these will make an excellent choice. Normally a hinge is just at 1 point. These are at 2 points, so they've got a lot more motion capable. This is an inexpensive approach. I got these at Tractor Supply. These were like $5 to $7 for 2 for each of these. So just a thought out there, next time you need a hinge, these could be a great solution for you. Next up, for the longest time, these are sort of the industry standard for Allen keys. Everyone will recognize this form factor. So I think they might have invented it, I'm not sure. But these are Bondus hex keys. And there's a lot of competitors out there, but I always keep coming back to these because these work and are reliable. But I found some other ones that I wanted to take a look at. Firstly are the really inexpensive Harbor Freight versions of these. Now, I've had really bad luck with the Harbor Freight inexpensive Allen keys. I have 2 sets of these guys here, and the balls have broken off 3 times off the ends of these. So I was kind of curious if this line of these would be equally fragile. And so I was just going to grab one of the somewhat small ones and pop it in here and see if they have a similar problem or if they bend, because the other ones are so hard that they're fragile and they didn't temper them appropriately. No, these just bend. Okay, so these are soft, but they bend. So that's not necessarily bad. They're going to round off. Then Harbor Freight has 1 step up from these, well, several steps up from these, which is their Icon line. And these, they claim, are made from S2 tool steel, which, if true, makes them much more expensive to produce because tool steel is more expensive to work with. So let's take a look at these guys. By the way, these are almost the same price as Bondus, so, rather than take a chance on these, you may just want to go with the name you know. I don't know. They're trying to get into the market, so we'll use these for a while and see how they work out. So here we have an assortment from the Harbor Freight inexpensive, least expensive, to their most expensive. We have Bondus, and we have Allen. This is an actual Allen USA Allen key. So maybe it wasn't Bondus that did it, because here's an Allen, although it doesn't have the ball saw on the end of it, which lets you have, rather than just vertical on a bolt, it lets you have a slight variation on angle. Next, I was going to quickly take these over to my my hardness tester and see what the hardness of the various Allen keys are. Before we head over to the hardness test, there's one more set, and these are sort of unique. These are Husky brand, which I think are made in the same factory as Craftsman. These Husky ones are sort of unique. They're the non-slip hex key set, and believe it or not, you wouldn't think that Allen keys would spin inside bolts, but sometimes they're sloppy enough that they do spin. I've actually had that problem before, and these have a unique feature, so let me pop these out. So if you look closely at these, they have little sharp edges, sort of cutting edges, relieved cutting edges essentially on 3 of the 6 flutes on these guys. And so they'll actually bite into the material. They also say S2 on the side. Presumably that means S2 tool steel. So as long as we're testing a couple of these, we might as well test hardness on all of them. And we'll be right back when I set this up. So as we get started measuring the hardness of these, hardness is only one measure of utility of an Allen key. Toughness is probably every bit as important, because like these where the balls break off, they could be very hard but fragile and the balls just snap off. So let's start with the Harbor Freight one that I've had problems with, and let's start with the hardness of this guy. And we'll set our 0. And that is a Rockwell hardness of 38. Next up is the Allen brand, and these are 44.5. Here is a Bondus. This one is 53. Cheapo Pittsburgh Harbor Freight, 57.5. Icon by Harbor Freight, S2 tool steel supposedly. By the way, how quickly this needle moves after you release the anvil is directly related to how hard it is. The harder it is, the less it moves, which is obvious because it's indenting less. 54.5. Last but not least, here's the Husky brand. But these are plated, so it may not be a fair test. These are also supposedly S2 tool steel. The plating is probably mostly for corrosion resistance, but it also might contribute something to the hardness. And 60, the hardest so far. So we have a variety of Allen wrenches here, starting with this one on the left. The Pittsburgh here was a hardness of 38. The Allen was 44.5. The Bondus was 53. The Pittsburgh was 57.5, very hard. The Icon was 54.5, and the Husky was 60, but they're plated, so I don't know if that's a fair test. On top of all this, I think what you'd ideally want in an Allen key would be case hardening, so it'd be very hard on the outside, but the core remains soft. So what you want to do is be able to flex a little bit, but have the edges remain sharp and be able to bite into the Allen head screw. So here's the range and here's the information. I can tell you from personal experience, these are not great at all. These are very reliable. They tend to bend. I've bent several of these. The Pittsburgh, can't say anything to them except they're very, very hard, which may be good, may be bad, depending if it's just case hardening. The Icon, also in the same boat. Time will have to tell. Probably at some point do some torque tests on them. And then these, which are very interesting, for Allen head screws that are a little rounded off inside that someone used the wrong size key in them. This might save your bacon, so I got a set of these just to try them out. Next up, solved the problem, which I might have mentioned in previous videos. I had a Schar's boring head, and it came with the boring bars in the boring head, which is really nice. It came with a whole set of carbide insertable boring bars. This is a 3/4 inch boring bar and a fairly short one, and they have flats on them, which for the Schar's boring head was really fantastic because you tighten the Allen screw down, and these guys were guaranteed to have the right relief behind the cutter because it locked the cutter in a perfect place. But when I got my other boring head, the Criterion, to replace the Schar's, when I got it at an auction from a retiring machinist, I used these boring heads in there, and the flats on these things locate it so that the cutting head is forward, and you end up rubbing on the back of the cutter, and you can't easily adjust it because the flat's wide enough that you try and turn it back a little, and when you tighten the Allen screw down, it goes and tries to rotate it back in place. So these weren't working for me. So I found another set here. And these are HHIP, and these guys are completely round, so they don't have the advantage of locking the cutter head in the exact right location. You need to do that manually, but on the flip side, you can do that manually. So these are pretty handy, and I'll keep these with my new boring head. The quality is pretty nice. I like the laser engraving on them with all the specs, including what the insert should be, the screw size, and the Torx wrench that goes with it. That's really handy. It's a really nice set. Comes in a case. I don't ever need cases. I don't have room to store my tools in cases. I have too large a collection to do that, so I never keep my cases. But it's nice that they provide it. We'll see how they work out in the future. These Shards ones were actually great and had no issue with them whatsoever. I just didn't realize that there was going to be a problem because of the flat until recently when I went to bore something out and I kept getting horrible surface finish. Last but not least, you might remember when I was working on my milling machine trying to replace the alignment pin for R8 collets, you have to take the nut off at the bottom of the spindle to get to the nut. And when I did that, I used a pin vise, but it wasn't ideal. So I found this set on Amazon, and I won't have that problem hopefully in the future. These are all replaceable jaws of various sizes, and they can be either the kind that grabs a slot like on the side of a ER collet, or they can be replaced with a arm that has a pin with removable pins in a bunch of different sizes, which is pretty fantastic. There's a wide variety of sizes between all these pieces. So this set was reasonably inexpensive and looks like it's cast. Looks like it's reasonably well made. So next time I should have whatever size I happen to need. I think that's a great find. The company is Anbull, and again, I'll put links for everything down below. So I hope you find these tools I've run across interesting. I hope you find it worth watching, and thanks for being here. Talk to you next time.